Radar. What is radar? Well, the term radar is an acronym meaning radio detection and ranging. It's a device which measures the time it takes for a pulse signal to be reflected from an object. The radar consists of a transmitter, which is the part that turns around on top. On your yacht, it will be contained in a box. Also consists of the screen that you see on the boat, and it has a TR switch which switches on between the transmit and receive. In our animation, it shows the pulse has come out from the radar, it's hit the target, most of that energy will carry on and never return. A small part of that energy will bounce back from the target and return back to the radar, and then it's shown on the screen. So here it is returning back and showing on the screen. So this is one shot of energy that's gone out to the target and returned back again. This happens really quickly. Then the radar moves on a little bit and it does the next one. So if it's just one target, the energy will hit the target, some of the energy will come back and it will show on the screen as one target or dot. If it's two targets and they're close together, as soon as the energy hits the first target, it begins to return back to the radar. If the length of that energy straddles the two targets, like it does here, just going over the two now, the first part of the energy has already started going back, and then as it straddles over the top of them, it can't differentiate between the two targets. So when that comes back to your radar screen, it comes back and it shows on your radar screen as only one target on the radar screen, not the two targets that we can see on our display here. This is known as pulse length discrimination. The shorter the length of the energy, the better definition you'll get on your radar screen. This is why when you go up and down a range, the pulse length varies in size. So if you zoom in, what was fog on the previous screen will look like individual marks on the next screen. And it's why part of the rules of the road say to zoom in and out. On a yacht radar, the beam width is about 5 degrees. So here's a representation of that beam width. And as that goes round, if it straddles two and the beam width encompasses both of those targets, it will come back on the screen as one target. On the second one here, the beam width goes in between the two targets. So when it goes in between the two targets, it will show on your radar screen as two independent dots on your screen. If it straddles the two targets, it will show as one dot. Here, your beam width is coming over an inlet. It straddles the inlet, and it's still painting on one side when it meets the other and paints on the other side. If the inlet is wide enough and it fits down it, it will show on your radar screen as an inlet. So the large inlet, it will show it. With a normal inlet, with a smaller inlet that straddles the screen, it won't. Here's a vessel off Torbay, the radar beam coming across, bouncing across, and it will show, it will bounce out, bounce back, and it will show the definition of the screen. If the target is like Roundham Head there, if it's solid yellow next to the water and a solid cliff, it will give a good position and a good definition of target. If it is quite shallow, it won't give that. Here it is coming in towards Roundham Head. The energy will come in, it will hit, and then it will bounce back. And that will show on the screen as quite a distinctive target of Roundham Head there. The shape that you can see on the chart will come back and show on your screen.
So we set up a radar, we've put it into north up mode, we've got Torbay, and it looks just like the chart. I want to do a position fix to see where we are. So looking at my radar, I can guess where I am quite accurately. I'm halfway across Torbay, pretty much equal distance, and a little bit further out from Roundham Head here than I am from either side. So I can make a judged guess on the chart where we are. But I don't want to do that. I want to make a much better position of where we are by using the VRM and the EBL. VRM is more accurate, so we need to look at something at the chart that we know is on the radar. So Roundham Head is quite prominent here. This headland here is quite prominent here. This headland here is quite prominent as well. The edges of the bay are a little bit more difficult because we don't know where it starts and finishes, and also with our beam width of 5 degrees, it will expend this headland out by half a beam width. So let's start with the VRM. So we bring our VRM out. and on Roundham Head down here, VRM 1.57 nautical miles. It's actually the same for this headland here, and on this one here, if we move it in a little bit, just about here, it's 1.43. Unfortunately, if we do VRM from this one and this one, we're not going to get a very good fix because they're directly opposite each other. But this one and Roundham Head will give us a fix because the items or the objects that we're looking at with VRM are 90 degrees from each other. We can put it on the middle of Roundham Head and it is 272. Okay, so if we plot those on the chart, it should give us where we are, and then we need to back that up visually, so we think we're in the middle somewhere. Back it up with our depth as well. Let's go and plot it on the chart and have a look. So we've got the information from the radar and we're going to plot our position. So the VRM from Roundham Head was 1.57. If we look at the latitude scale on the edge of the chart, there's 1 mile, 2 miles, 3 miles, 1 mile, 1.5, 1.57 is going to be about there. So if we measure that with our dividers, 1.57 is there. We'll take it from Roundham Head and we'll mark the line here. We said from the top of East Shag here, that piece of land there, the distance was 1.43. 1.12343 is there. So if we measure that, it's slightly smaller. So from there, 1.43 is there. So we take that from the rocks on East Shag, mark it off. Okay, where they cross over, so bear in mind at the moment it's only a 2-point fix. Where they cross over, at the end of the lines, we put an arrow, as we would with any position line, and we're going to have a look at the bearing from Roundham Head. So the bearing of Roundham Head was 272 degrees true, so we're going to use our plotter, dial up in the middle of 272, 272 there, and when we pop it on there, we want the small arrows towards the top, so we're going to put that on Roundham Head here, and we're going to line up the vertical lines or the horizontal lines on our plotter so it lines up, and then with Roundham Head. Okay, so there's Roundham Head, mark the line across, and we have the position line. Okay, so we think we're in this position. Do a dot and a circle. It's midday, so we're going to put the time at midday. We put an L and put our log reading, which 53 miles. And then to double check this, we're going to look at this visually. Are we about halfway between East Shag and Brixton Harbour here, and a little bit further out than that from Roundham Head? And we're going to check our depth. So our depth is around 10.5 meters plus the height of tide that we've worked out above chart datum. So we're trying to use all the information we can to back up our position of where we are. So to recap, VRM is much more accurate to use and easier to use, because you could just measure the distances on your VRM, then use your dividers. Make sure you've got a nice pair of dividers. Use your dividers, mark off where you are. You can use bearing lines. Bear in mind, if we are going to use the headlands, we've got to move them in half a beam width, so we need to know what the beam width of our radar is. It'll be in the manual, but most leisure radars will be about 5 degrees, so we need to move them in about 2.5 degrees. If it's a spot on point or a buoy, we can take that straight away and just pop the line on and give our position. Okay, it's really easy to do, and also it's from an independent source.
Thank you for watching our video on RWA radar. We appreciate that. There's a lot of videos on the City Sailing YouTube channel. There'll be more on radar, Rule 19, how to apply it. If you want the radar certificate, please come along to a City Sailing RYA radar course, which will be running in the near future. Thank you very much. This is Paul, City Sailing, out.